Okay, I'm asked to write a possible equation for this graph here. I'm not given any points, so I can kind of pick and choose my own points, but the key here is to come up with a polynomial equation that has the right kind of leading coefficient, the right h value, the right kind of k value. If you remember, kind of the generic, well, first of all, we see that the end behavior of this graph looks like this, so I know right away this is going to be between a third degree or a fourth. This is going to be a third degree. All right, so it's going to be the cubic function. So a parent cubic function is this. And if you recall, that looks kind of like this. Now we need to figure out, we'll call our graph g of x. We need to come up with a coefficient, the right kind of h value, and the right kind of k value to reflect the graph that is actually shown in the problem. And here I see that the a value, right? First I'm going to ask, is it positive or negative? Well, I know that the end behavior reflects that of a negative leading coefficient. So a must be negative. And it also looks like the graph is somewhat stretched. So I'm going to go ahead and make a negative, we'll just do -5. That means it's going to be stretched in the vertical direction and then flipped over the x-axis, right? Both sides. So if I stretch and flip the parent function, that's going to then look like something like this. Now I still see that I have more work to do. I need to shift this function over to the left, h units, and down, k units. Again, it doesn't really matter what the values are here, so I'm just going to, the key is to make sure you have the right kind of sign. So shifting an h value to the left means that it is going to the negative, so we'll just do -2. And to shift something down, we need to subtract a k value. We'll just do subtract 4. Clean this equation up a little bit, and minus a -2 becomes +2 cubed minus 4. And this is an appropriate polynomial equation that looks something like what was given to us, in the problem. This highlighted graph here. If I have any question, I want to check my work, I can actually just go ahead and type in what I came up with, x plus 2 cubed minus 4, and see what the graph looks like. And sure enough, that graph looks in the same general kind of shape as what was given to me in the problem. So the key here was to have a negative coefficient out front, right? That flipped the graph over the x-axis, giving me this kind of end behavior. A coefficient that's greater than 0, the absolute value of which is, that stretched it. A +2 inside the parentheses here shifted the parent function 2 units to the left, and a -4 here shifted in the vertical direction down 4 units. So those were the key things that I came up with. The specific numbers that you kind of plug in here can vary, but the key here is that the k value must be subtracted, the h value must be added. So there's a plus inside the parentheses. We need the negative out front with a coefficient that's greater than 1.